Hello everyone, Radhe Radhe, and welcome back to my channel. Today we are solving a LeetCode problem of the day. This is named max dot product of two subsequences. So let's read the problem and then we'll begin. We have been given two integer arrays, nums1 and nums2. Then we need to return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. So the subsequences should be of same length, and then the definition of a subsequence is given here, right? So there is not much to the problem. You can consider this test case. So in this case we have been given a nums1 as 2 1 minus 2 5 and the second one 3 0 minus 6, and the answer for this is 18, because if we take this 2 and the first subsequence could look as 2 and minus 2, and the second subsequence would look as 3 and minus 6. So we can multiply this 2 with this 3, we'll get a 6, and we can multiply this minus 2 with minus 6, so we'll get 12, and 12 plus 6 is 18, so we get a 18 here, right? So this is the problem. The main thing is that the problem says we need to choose non-empty subsequences, so we cannot choose an empty subsequence. So that is out of our question, first of all. Second of all, the main thing is length of subsequences should be same. Length of both subsequences must be same. Alright, one more thing before beginning the solution. One thing I need to make sure is that before solving this problem, I think you should be very well comfortable with LeetCode hards, and you should be comfortable with dynamic programming. Otherwise solving this problem is I think just a waste of time. You should solve some easier and medium problems, right? So anyways, let's begin. The main thing in this problem is these two statements, that the length of both the subsequences must be same. So if our the first array is something like this and the second array is something like this, then I need to choose the subsequence such that, so I'll take one example. So let's say I choose a subsequence in the first array as something like this. So this is a 3 length subsequence. So similarly I need to take 3 length subsequence in the B array also. So this is the A array, this is the B array, let's say for now. So if I choose 3 elements from array, I need to choose 3 elements from array B as well. So let's say I choose these 3 elements, and we need to maximize this result, right? We need to return the maximum dot product. Alright, so first of all I would like you guys to think in the direction that if this statement wouldn't have been there, the length of subsequences must be same. If the length of subsequences could be different, then what would be our approach like? Let's say if we wouldn't have been given a dot product, maybe we would have given a sum. Maybe we need to maximize the sum of chosen elements, maybe something like that. So in that case, don't you agree that we just need to sort the array and we'll continue taking the maximum elements, right? We can sort this array, and let's say if our array would have been something like this, 5 10 15. So if we would have if the question would have mentioned that we need to find the maximum sum, so we would have taken all the positive integers, right? If the length was allowed to be different. But in this case the length has to be same, right? So if length has to be same, first of all the greedy approach doesn't work. I'll show you guys with the test case. If we had an array like 10 9 8 and b as minus 1, let's say 10 and 20, so I cannot just choose these 3 biggest elements from array A and then take these 3 elements from array B, right? Because this is a minus, so this will result in minus 10 plus 90 plus 160, right? Otherwise if I take this part, this is 9 into 10 plus 8 into 20, so this is 90 plus 160, right? 90 plus 160, which is greater than this result. So no matter what strategy you think of greedily, the greedy approach wouldn't work, because you don't actually know whether you want to include this current element to the final subsequence, or you do not want to include this current element to the final subsequence, right? You do not know. How would you know? So that is one thing. So that means we need to try out all the possibilities, and then what comes into our mind is dynamic programming, right? We can try all of the possible subsequences, and there aren't as many of them, right? So that is one thing. Now, in order to find out all the possible subsequences, what do? If you remember this trick, when we were learning dynamic programming, there was this trick called pick non-pick technique, right? We can either take this element into our final subsequence, or we can ignore this element and move on to the next one, right? So this was a technique we learned when we were learning dynamic programming problems, right? So similarly, we can follow a similar approach like that in this problem. So let's say I'm on the first element. So for I will handle both of these arrays separately, right? So for the 8th array, I could either take this element into the final subsequence, or I cannot, right? We only have two choices for this element. Similarly, for this bth element also, I have two possibilities. Either I could take this element into account, or I do not take this element into account, right? So at last, what we have is four choices. Either I can take this ith element, or I can ignore this ith element, or I could take this jth element. I could take this jth element, or I can ignore this jth element, right? So suppose I want to include this ith element into my final subsequence. If I want to include this ith element into our final subsequence, then I will move this ith to the one step forward. And now, don't you agree that I cannot take any more elements from the array A, because I have already taken one element from array A, right? And I need to pair this up with an element from array B, because at the end we need to maximize this thing, right? AI into BI for all I from 1 to m, where m is the length of the subsequence that we would have chosen. We need to maximize this part, right? So this comes in terms of pair, right? We need to pair each element of AI to an element of BI, right? So if I have chosen this element, if I have taken a decision that this element must come in our final subsequence, then I cannot include this element just after taking this one. First I would need to pair this element with any element, right? Either we could pair this 10 with -1, or this 10 or this 20, right? Whatever we want. So that is what I'm saying. If I have chosen this element and taken this into account, then I cannot directly choose this 9. First I would need to choose this from this array B, right? I need to pair this 10 with an element from B. So I'll try either I take this element into our final subsequence, or I do not. If I take this element into our final subsequence, then we add this thing to our final answer, right? 10 into -1. If I choose to ignore this particular element and move on to the next one, then I do not include anything to the sum, and I just increment j one step forward, right? And now I have two choices again. Either I could include this 10 to my final subsequence, or I cannot. If I choose to include this particular element into my final subsequence, then I could add just 10 into 10 into my final answer, right? And I could move this here, right? So now what I have done is I have found a valid pair. I've taken this into account, and now I'm left with I equals I is here and j is here, right? Now I can start forming another pair. So I can start choosing an element from A again, right? Now I can take this element into account, or I can not, or I can skip this element and move forward, right? So this is what I'm saying. If I choose an element from array A, or if I choose an element from array B, then I would need to choose the element from the other array, right, to pair that particular element, because the length of the subsequence must be same. So AI and BI occurs in pair, right? So that is what I'm trying to prove here. So now once that is done, the problem is pretty simple. Now we can now just discuss what are the number of states. So the number of states is nothing but number of changing parameters, right? So what are the changing parameters in this problem? Let's see. So this I is changing. This I is the pointer to the A array. So this I is changing. This J is changing. So we have two changing parameters. Again, if we choose this particular element, then we would have we need to remember if we would have taken this element into account or not. If I would have taken this 10 into our final subsequence, then I cannot take this 9 into my final answer, right? So I need to remember if I had taken this 10 or not. So I need another state, right? So for now, let's just see that if these three parameters can lead to our final answer. Now I define my state as state could be one of three things, either 0, 1 or 2. So I'm saying that if my state is 0, that means I could take both the elements without any trouble, right? So I could either I could take this 9 if I want to, or I can ignore this 9. Similarly, I could take this 20 if I want to, or I can ignore this 20. So we are free to do whatever we want if our state is 0, right? If my state is 1, that means that I have chosen an element from array A, and so I cannot choose an element from array A again. I need to pick an element from B. So state 1 means that. State 2 means I've chosen an element from array B, right? I have chosen any element from array B, and now I cannot choose an element from array B again. I need to choose an element from array A. So that is what state 2 means. So we have these three states which will help us to build the answer further, right? One thing that I want to explain is that as soon as we pair these elements, one element from A and one element from B, the state could be initialized to 0 again, right? Because now our problem is reduced to we have found we have constructed one pair, and now we can begin again. We can either choose this 9 or ignore this 9, and we can either choose this 20 or ignore this 20. So now our state would become something like 0 again. Again, if I choose this 9 into my account, then my state would become 1, because now I cannot choose this 8 again. I need to choose an element from B. Similarly, if I choose this 20 first, then my state would be 2. I cannot choose any element from B, and I would need to choose an element from array A. So these three changing parameters are what will help me to construct the answer, right? There's just one more catch, that it might happen that we have chosen none of the elements when we are standing at the last index, right? So when I'm standing at the nth index, if n is the size of A, let's say, and I have chosen none of the elements in my final subsequence, so this condition is not allowed, right? Because we have to choose non-empty subsequence. So at least one element has to be there, right? So I'm saying if I land on the last index and I haven't chosen any element into account, or I haven't constructed any pair, then I need to return int min or minus infinity, or I could say minus 29, because this is not a valid condition, right? It is not allowed to not include any element. We have to choose any one. So if that is the case, that we haven't included any pair, we haven't constructed any pair, so that means this is not a valid condition. This is an invalid condition, so we'll return a minus 29. So there is one more parameter through this DP state, that is let's call it done. So done equals to true means we have constructed a valid pair for now, and then we'll just move on to the next pair. So we have constructed, let's say we have constructed this pair 10 with a 10. So now we set this done to true. We have constructed a valid pair. Now even if I land on the last index, right, I do not actually return -29 in that case. I actually return a 0 in that case, because I have created my final or I have created a valid pair. This is not an invalid condition, this is a valid condition. So I could take this particular I could take this particular subsequence into my final account, right? So that is what I'm saying. So these are 4 changing parameters. I hope I'm not confusing you a lot, but I think this is not that hard to see. We can begin discussing the code and then we'll go from there. So I've initialized my 4D DP by this is the ith parameter, this is the jth parameter. Then we have 3 choices, 0, 1, 2, and then we have a boolean variable 0 and 1, which is done, which indicates if we have constructed a valid answer or not, or valid pair or not. We'll discuss this base case at last. First, let's begin discussing these problems. These conditions. So this is straightforward. If the DP of this particular state is it not -1, then we'll return whatever is in the final answer. Then we have 2 choices. First for A and first another one for B. I could either take this element of A, or I can skip this element. Similarly, I have 2 choices in A and 2 choices in B again, right? So I'm saying if my choice is not equals to 1, that means I haven't chosen the last element as A itself, of A or of A itself. So that if choice is not equals to 1, that means that either I had taken an element from B, or I have just constructed a pair. So I'm open to take anything now. So choice should not be equals to 1, because if it's equals to 1, then that means that I have just taken an element from A itself and I cannot take this element again, right? So if choice is not equals to 1, then I have 2 choices, either pick or non-pick. If my choice equals to 2, that means I have just taken an element from B. So in that case, I could take the element from A and add that to my answer. I add that to my final answer, and I could set this condition as true, or done variable is true, because I have constructed a valid subsequence. Why do a bj -1? Because if I had taken this, let's say this j into account, this j into account, if I have included this element into my final answer, then this j would have been incremented to here, right? So whatever is j -1, that is my value which I have included in my final which I have to include in my subsequence. So if I'm standing on this j, and if my choice is 2, that means I have taken the previous jth element, right? So I've taken this 10. So that is what I'm saying. So b of j -1 into a of i. A of i means the current element. So we can add this pair. We can choose to include the current th element, and we can pair this with the last chosen element from B, and then we can set this condition as true, because we have constructed a subsequence of at least length 1. Otherwise, if the choice was 0, that means we can choose this current element or not, right? So in both the cases, in this case, I set this choice equals to 1, because I have taken the current element into account, or I'm choosing the current element into account, right? So I'm setting this condition as 1. In this case, I'm setting the condition as 0, because I've constructed a valid pair, and now I'm free to take an element from A or from B, right? I'm not obliged to take an element from A or B, because I've just constructed a pair here. And now this is the straightforward condition. I could choose to include or I could choose to skip the current element. So in that case, choices and done, everything remains as it is, and the first variable, that is choice for A, this A, becomes maximum of pick and non-pick. Similarly, the second one is the same thing again. If my choice is not equals to 2, because if it would have been 2, then I cannot take an element from B again. So that is what I'm saying here. There are 2 things, either I could take or I can skip. If my choice was 1, that means I have taken the last element from A, right? So I could pair this thing. So a of I minus 1 into bj, and then the same thing again. I set this condition to true, the choice becomes 0, or if my choice was 0, so then I'm willing to take this bth element into account. So I take this bth element, I make the choice equals to 2, rest of the things remains as it is, or I can choose to skip this current element. So in this case, the everything remains as it is, and second becomes maximum of take and not take, or pick or not pick. Now my dp of ij choice done equals to maximum of first or second, right? And that's about it for the problem. This is, I'm just setting the dp, I'm initializing the dp to -1, and I'm just calling the function over here. Now the last thing that remains is what I'm doing in the base case. So one thing is that if I have an array something like this is the A array, this is the B array. So if I choose this, if I want to choose this element into account, so if I had chosen this element into account, then I would have landed to the last element, right? This is the nth element. If I had chosen this element, suppose j was here and I is now here, right? Now I cannot just terminate my function. If I had chosen this element, we have these three elements left to pair this element with, right? So we can try all these three possibilities from j to the length of b. We can iterate from j to the end of b, and we can see whatever is the maximum of a of I into b of j, or b of t. Let's say if t is going from j to m minus 1, if the length is m here. So I could iterate, I could check what is the multiplication of this thing, then I could check what is the multiplication of this thing, then I could check what is the multiplication of this thing, and I could take the maximum of all such cases. Similarly, if I'm on this b last element, now I'm here, right, on the mth element. If I had chosen to take the last element into account, the last b element into account, and if let's say my I was here or my I was here, so now I have three choices again. Either I could pair this element with this I, or I could pair this element with this I, or I could pair this element with this I, or I cannot pair this element at all, right? So I could just calculate what is the multiplication of this thing, what is the multiplication of this thing, what is the multiplication of this thing, and take the maximum. So that is what I'm doing here. If my I equals to n, that means I have just taken the last element into account. So I'm just checking if choice equals to 1, that means I have just taken the last element into account. So I try all the possibilities. I go from j to m and I calculate b of t into a of I minus 1. So the last element of array A, and then all the elements from of array B from j to end of the array, right? And whatever is the maximum. Otherwise, if choice was not equals to 1, then I could, if my done was true, that means I have found a valid subsequence, then I could return a 0, or I could return int minimum. Because this condition is invalid, empty subsequence is not allowed. Similarly, I'm doing the same thing for B, and that's it. This code gets successfully accepted, and that's about it for the problem. This is indeed slow. Let's analyze the time complexity. This is m into n, so this is fine. And why this is m into n? Because we have initialized the array as this is the size of array. This could be till 500, and this 3 into 2 is just 6, so we can ignore this constant, right? So this is just 5 into this is just n into m, right, or n square you can say. So that's about it for the problem. I hope you got it. This was a little trickier to explain, I'd say. This wasn't very difficult to do. I think this was like any other, any other problem of DP. There was just this thing, this choice thing, and then this done variable, which we would have, which we need to take into account. Otherwise, I think this is fine. And if you haven't got the solution, then please ask in the comment section, or you can just watch the video again. I've tried my best to explain this, or you can read the editorial or solutions from here, right? People would have, I'm sure people would have written easier solution to this problem. Anyways, I think we're done for today. Thank you for watching, and Radhe Radhe.